All right. Good morning, everybody. Welcome to the CH-47 academic world.
Chinook is the world's most efficient, reliable, and versatile heavy-lift helicopter. It routinely does what other helicopters cannot. The Chinook flies with larger and heavier loads in demanding conditions that keep other helicopters on the ground. The secret is in the Chinook's tandem rotor design, with its efficient size and system capabilities that can move more payload faster at a more economical rate than any other rotorcraft, even in high elevations, turbulent winds, and hot and humid climates. With its stabilizing sling load system that utilizes up to 3 external hooks, the Boeing Chinook may move a vast array of large and awkward loads to critical locations at airspeeds up to 130 knots. A digitized cockpit management system, vibration reduction technology, and extended range fuel systems enable crews to fly complex missions with ease. Additional features that allow for water landing, operation in desert environments, and search and rescue extend the Chinook's already long list of mission capabilities. Long a mainstay of the United States Army, with a fleet of more than 400 CH-47s, Chinooks also serve more than a dozen other international military forces as their transport helicopter of choice. The Chinook is also a lifesaver in civil disasters, handling relief missions in floods, hurricanes, fires, earthquakes, avalanches, and snowstorms, over 4 decades on 6 continents. In the United States, the Army National Guard conducts civil relief, humanitarian, and environmental support missions across the country. Guard units from 10 states operate Chinooks to handle everything from engineering tasks to rescues. These missions often extend beyond state boundaries, making the Chinook a national asset. In the mid-1990s, television news viewers watched a Chinook lift needed equipment into the flood-ravaged Des Moines, Iowa water plant to return that vital facility to operation for 250,000 residents. Chinooks from California rescued stranded mountain climbers on Mount Whitney, an event documented on the TV show Rescue 911. 3 cross-country skiers stranded by an avalanche near Aspen, Colorado, owe their lives to a Chinook crew. No one else could have reached the skiers and saved them from brutal cold and sure death. A Pennsylvania Chinook lifted a bridge into a state park, saving wetlands from damage by trucks. Throughout a winter night in 1996, when no one else could fly, 4 Pennsylvania Chinooks flew in sub-freezing temperatures and blinding snow, completing heroic rescue missions to save 65 people from raging winter floodwaters that devastated small towns near Wilkes-Barre, Pennsylvania. Halfway across the globe, the flooding Sava River stymied U.S. Army engineers tasked with building a pontoon bridge for NATO peacekeeping forces moving to Bosnia. The engineers called for help from 4 Army Chinooks, which completed the longest pontoon bridge assembly since World War II in just 2 days. Through a record-breaking fire season in 2000, commercial and National Guard Chinooks fought dozens of blazes throughout the U.S., dropping millions of gallons of water and retardant. A Chinook can drop up to 3,000 gallons of water or retardant mix, more than most fixed-wing aircraft, with pinpoint accuracy even in 45-knot crosswinds on the deadliest infernos and return with another load in minutes, unlike converted prop-driven bombers, seaplanes, and transports that may spend valuable hours returning to staging areas many miles from the fire line to refill their water tanks. Chinooks perform life-saving missions lifting food, water, and building supplies into Miami, Florida after Hurricane Andrew, when storm devastation made roads impassable and survivors might have starved. The U.S. Army's lifting capabilities are not, however, limited to emergencies in the United States. U.S. Army Chinooks carried tons of food, water, medicine, and clothing to save thousands of lives after Hurricane Mitch devastated several nations in Central America. Although other military forces have far smaller Chinook fleets, they also utilize their aircraft across a full civil mission spectrum. Chinooks facilitate U.S. and international force combined arms operations by carrying everything from beams to bullets, including missiles and fuel for rearming and replenishment, to keep combat assets near the front lines and ready to fight. The Chinook's ability to refuel other combat platforms keeps operational tempo high, making the CH-47 a genuine force multiplier for military services fortunate enough to utilize them. Military Chinooks from several nations successfully completed strategically important missions in Operation Desert Storm, continuing a long heritage of service extending from the Vietnam War. Kurdish refugees fleeing Iraqi suppression after the war would have died in the barren mountains between their homeland and Turkey without the lifeline provided by Chinooks from the United States Army, Britain's Royal Air Force, and the Spanish Army. More recently, British Chinooks participated in a record-breaking 3,000-mile flight from England to Sierra Leone, where they transported civilians out of danger during the Civil War and carried soldiers for a surprise hostage rescue mission. Throughout this assignment, the Chinooks performed flawlessly while transporting hundreds of people away from the ravages of war. Today, Chinooks of the Royal Netherlands Air Force are performing similar missions for the United Nations in Eritrea, a district of Ethiopia where civil war also rages. Despite the arduous climate and primitive conditions, the Dutch Chinooks are performing well, supporting United Nations forces in a variety of important peacekeeping missions. The Chinook is a lifesaver, but it's also a builder. CH-47s routinely carry large towers into the wilderness to extend power lines in remote areas. Commercial Chinooks lift tons of logs from forests for paper and timber mills, flying up to 2,500 hours each year to avoid ecological damage to surrounding forests. As one Chinook pilot said, "It seems like the more you use Chinooks, the better they fly. It's hard to realize just how much the Chinooks can do until you actually see them in operation." These examples just begin to tell the Chinook story. Nearly every day, the Chinook is serving on missions like these and more. The Boeing CH-47 International Chinook routinely does what others cannot, so that the only limit to its mission capability is the user's imagination.
That was just one of our nice little short videos we've got. If I failed to mention it before, there are only two types of helicopters in the United States Army inventory. Y'all know what they are? Have you heard what they are? Probably not going to like to hear this, but it's only Chinooks and sling loads. We are the only ones that can really carry ourselves. In front of you, you have our student handout. For the next 23 training days, we're going to cover everything that's in there. That is a good reference to keep in the future. There was a theory of operations manual out when the D model came out in 1984. We have taken, it was full of pictures. We've taken a lot of those pictures out, put a lot more information in there. This should be something that you should reference many years from now. We keep it updated on ChinookDoctor.com. the website we told you about before. If you'll go on there, you'll notice that each one of these lessons in here are posted. If there is an update, it will say new. You print it out, put it inside there. The Dash 10 you need to bring with you every day if you can. But for the days that we have weight and balance, PPC, you're going to need to have your large Dash 10 with you anyway because of the charts that are in there. Today's terminal learning objective: describe the general operational characteristics, systems, and limitations of the CH-47 Delta. I am going to go through with the slides today, introduce the aircraft to you, talk a little bit about the systems, and each system that we're going to talk about today we will go in depth in as we go through the course. And it's going to be in the classroom. We've given you your student handout. Models. Anybody got any idea how many different models of the CH-47 we've got in the U.S. Army inventory right now? We got a bunch, thanks to Task Force. We are migrating to the F model, but the Task Force has always had the special ones. We'll go through some of them. Right now here at Fort Rucker and a lot of throughout the Army, we have the CH-47 Delta model. That's what the cockpit looks like on the inside. As we get through this, I'll show you some of the differences and how to tell you what engines. I mean, we've got the CH-47 Delta out there, but we've got 712 engines here, and we've got 714 engines. That master caution panel right there will be my dead giveaway of which set of engines I've got. With the 3 columns there, it tells me I've got 712s. Once we go to the 714 engines, they did an MWO, and we've got 4 columns and added some more lights. Task Force. These are the big guys. They have the MH-47 Delta, Echo, and Golf. This is what their cockpit looks like. A lot more to what we're going through with the F model. The new guys, when you get into this new cockpit, be aware that one of you needs to be looking inside here and seeing what's going on, and at least one set of eyes need to be on the outside. It's too easy for everybody to look at this new equipment on the inside and forget where you're flying and fly into something. And here's what we're going to, the F model. And there's the cockpit for the F model. This is where we're going. Some of you will have the opportunity to come back once we start doing the differences course here and you start flying the F model. Some of you will have the opportunity to come back and go through that. LSA number 1. Describe the general operational characteristics, configurations, and limitations of the CH-47 helicopter. Rotor dimensions. Look at the rotor dimensions that we've got now. 98 feet, 10.7 inches, 60 feet wide. You've got to find a bigger parking spot. You've got to find a larger confined area to go into now. It is a tandem rotor system, 3-bladed counter-rotating rotor system. Rotor heads are going to turn the opposite. Always remember that the rotor system is going to turn into the left side. If anybody ever asks you which way the forward rotor head turns or the aft rotor head turns, it's always going to rotate into the left-hand side of the aircraft. Some of the other dimensions, and these are some that I really want to point out because they are very important. The 7 feet 8 inches when it's static. It actually droops a little bit lower than that when the rotors are not turning. When the rotors are turning, it can drop down to 4.4 inches. That's very important. Very, very important. Because I don't care how often you brief your passengers before you go pick them up. You tell them that their ramp is our primary means of entrance. A lot of times you're going to notice that a crew member is going to drop that front cabin door on the right-hand side, and people see that door and they want to rush up there and get in because they want to sit up front. If they're coming from the front part of the aircraft, that rotor system, 4.4 inches, can dip down that far. It's not conducive. Rotor blades and bodies do not mix. 18 feet 11 inches in the back. With the rotors turning, 16 feet 1 inch static. That becomes important because you've got to get up on top of this aircraft in pre-flight. And I'm going to tell you from experience, that's a long fall. There are work platforms above the engines right there that we lower down so that we can climb up and look on the rotor head. gotta be careful. Remember where you're at and do not step off one of those. Some more of the dimensions. From wheelbase, our wheelbase is 22 feet 6 inches. Component locations. To make it easier to identify the components, where they're at, we've broken it down into a couple of different things. Everything on the left side of the aircraft will be number 1. And when I talk about these systems here in a moment, you'll see that our electrical system on one side is number 1 system. Everything on the right side is number 2. If it's on top, we consider if one component's on top of another component. 9 out of 10 times. There are some exceptions, and we'll point those out in the class. The component that's on top will be number 1. The component that's on bottom will be number 2. So now we've talked left side, right side, top and bottom, and then front and back. Our flight control system broken down into 2 systems. Up front in the forward pylon area will be number 1 flight control system. And the back area will be number 2. Makes it easier to identify the components, makes it easier for us to write things up. Fuselage stations. Anyone here remember what a station is? What's a station number? Station numbers are numbers that we've identified as being in front of the aircraft approximately 21.5 inches or 21.5 inches. 2 inches in front of our PDOT tube is station 0. That is inch 0. For every inch back towards the back of the aircraft, that will be a station number. So if we stock station numbers, it's inches back from our imaginary, we call it a reference datum, in front of the aircraft. Some of the major component or major areas that we're going to be concerned with, from station 21.5 to station 95, for you gentlemen, that's home sweet home. That's the cockpit. From station 95 to station 120, we call that our companionway. When you walk into the aircraft on the right-hand side, and to get into home sweet home at station 95, you've got to go through the companionway. When you walk into the companionway in the middle of the aircraft, facing the front of the aircraft, on your left-hand side will be what we call the flight control closet. A little bit farther on the other side of the flight control closet will be the avionics compartment. On the right-hand side of the aircraft will be our heater compartment. And that's all between station 95 and station 120. Between station 120 and 160 is the entranceway to the aircraft. On the right-hand side of the aircraft, there is a little cabin door that drops down that you can walk in. Also, station 160, when you get inside the aircraft and you look on the floor, you'll see a red line. We will not pull any cargo any further up than that red line at station 160. From station 160 to 486 is the cabin area. Station 249 will be underneath, will be the forward cargo hook. Station 331 will be our center cargo hook. Station 409, aft cargo hook. And then station 486, when you walk out on the aircraft for the first time and you start pre-flighting, you'll notice that the ramp hinges. That is where the cabin area stops, station 486. One of the main formers that runs around where that hinge is at, that's where the cabin area ends. And then from 486 to 630 is the ramp area. And then our engines, T55-GA-714 alpha engines. You'll find out when we talk about our engines in a moment. We've got power for days. At 50,000 pounds, which is our max gross weight, we lose an engine, we can still maintain flight. This aircraft's designed to fly during day, night, VMC, IMC, and water operations. Maximum gross weight of this aircraft, 50,000 pounds. With crew and a full bag of gas, the aircraft approximately weighs 31,000 pounds. And then that leaves us 19,000 pounds for cargo. Again, this is our fuselage section. It's a semi-monocoque structure, but it is divided into 4 sections. Cockpit section, cabin section, ramp section, and aft pylon section. All right, we're going to get into emergency equipment. Some of the emergency equipment that we have in this aircraft, we have 3 fire extinguishers. There is one located in the cockpit on the pilot's side. the right-hand side. There is one located at station 120 above the avionics closet. And then there is one in the back, station 486, in the ramp that the flight engineer will use a lot of times when we start our APU. These fire extinguishers are not to fight large fires or fuel fires. They are for personal use. If the aircraft catches on fire, get everybody out of the aircraft, and if you grab those fire extinguishers and somebody's on fire, fight that individual. Do not try to fight the aircraft fire. This aircraft's a lot of magnesium in it, it's going to go quick. We can replace the aircraft, we can't replace individuals. Emergency escape acts. In the unfortunate event that we have to cut ourselves out of the aircraft, we have an emergency escape axe. It's located at station 200 on the right-hand side. When you walk inside the cabin door up front on the right-hand side, first three-man troop seat to your immediately left will be this emergency escape axe. When you pre-flight and it's on the checklist, just look to make sure it's there. It's a piece of steel, it's not going anywhere. If you pull it out, you stand the chance of dropping it, breaking a toe, or putting a hole in the aircraft floor. Emergency exit lights. These lights are designed to illuminate in the event you have a hard landing of 3 Gs or more. And at nighttime, they give you a valuable asset of being able to tell you where the exits are on the aircraft. When I walk into the companionway or the cabin entrance on the right-hand side, immediately on top of that door will be an emergency exit light. Right across the cabin area on the other side, there will be a panel. And there will be a light above the top of it. And then in the back, the ramp area by the auxiliary power unit, there will be another light. Again, when we have a hard impact, these lights will illuminate and show us the exits. If I've got to escape out of the aircraft and it's nighttime and I can't find a flashlight, I can reach up, I can pull it out and open it. As long as that red handle's pulled open, they will be used as a flashlight. You can activate them from the cockpit. You can arm them, disarm them, and that's one of the things you're going to have to work out with the checklist, because if they're not properly turned off with the checklist and you leave them armed and the battery's plugged in, it will drain our battery down because it's constantly recharging those batteries that are on the inside of it. Cargo compartment. This aircraft, again, when we talked about our rotor dimensions earlier, this aircraft is huge. Everyone should know what a Humvee is by now. The military's got them, and you can see those huge ones rolling down the highways and the civilian version. We can put 2 of those in the back of this aircraft. It's huge. Not much room left on the inside when we pull them in there, but there is a lot of room. It's 90 inches wide, 78 inches tall, and 366 inches of usable cabin area in the back. When I say usable, that's from station 160 back to 486, or 120 back to 486. We usually don't pull anything above the red line if it has weight on it, but the cabin area does extend 366 inches. As far as not being able to go past station 160, the areas that are on my slide that are marked in red is a treadway area. If we pull wheeled vehicles in here, that's where we try to put them. And underneath that part of the floor right there from station 160 back, there's vibration absorbers underneath the bottom of it. It strengthens the floor a little bit more than the rest of the floor. And having those vibration absorbers that are in there, you keep the vibration from the load transferring to the aircraft, or from the aircraft to the load, and things bouncing around in the back. CG problems with this aircraft, when we do weight and balance, you'll understand that CG is not a real big problem with this aircraft until we start putting things on the bottom. We can, in those areas, uniform distributed loads, we can put those out throughout the aircraft. When we put loads in the floor, we are not to exceed 300 pounds per square foot. Does anybody have an idea what shoring is? Shoring is nothing more than when I do exceed just 300 pounds per square foot, that I can take plywood and spread that load out a little bit farther to reinforce it. Passenger configuration. There is one seat in the companionway, the troop commander's seat. I want to give a little bit of caution about the troop commander's seat on how it works. What happens to this troop commander's seat is it folds down, it's hinged on one side. There is a handle in the front of it. You pick this troop commander's seat up, it's supposed to lock in on some formers on the flight control side of the companionway. You push down on it, and a lot of people make sure it's locked and they crawl over it. We can pull our seats up without having to pull them out to bring our cargo like our Humvees on the inside. Normal emergency and rescue entrances and exits. On all of our windows, there is a yellow tab. All of the windows that are in the aircraft are an emergency exit. You pull on the yellow tab, it will pull out an inner liner around that rubber ring, and you just push the window out of the way. Same goes with the window that's in this big panel and with the panel itself. It also has a yellow pull tab. When you got somebody as big as I am that can't fit through that little window, you push that big panel out and they should be able to get through. This panel is on the left side of the aircraft. When you walk in from the right side through the cabin entrance there, this is the one that's right straight across. On the inside of the aircraft, that second emergency exit light that I talked about will be on just right above that panel. Those are your emergency exits. Also in the cockpit, your doors are jettisonable. You'll have handles in the cockpit. You'll pull on them and they'll fall away. The cargo loading and ramp area, it is also an emergency exit. A ramp is operated hydraulically. It comes up hydraulically. We'll talk about this during our utility hydraulics class. We use hydraulic pressure to bring it up, but it free falls down. It can be used as an emergency exit. On the ramp, we have that 300 pounds per square foot limit that we have to be concerned with, but on the ramp we've also got to be aware that in a total area of the ramp we cannot exceed 3,000 pounds. Inside the ramp there is a door. When the ramp comes up about 4 to 6 inches from getting to the up position, it will stop. This ramp door will shoot out, and then the ramp will come up and it will seal. You'll hear me and probably Tom refer to it as we go through this class as the ramp tongue, but it's called the ramp cargo door. It also has some escape panels on it. There will be a little yellow panel instead of a window in the middle of it, a yellow panel with a pull tab. You can pull it out and push that panel out. Also, on the bottom of that tongue when it comes out, there will be a big yellow handle. If that little panel is not big enough for me, I can pull on that yellow handle. If I'm right side up, the door will fall away. If I'm upside down, I can pull that handle, then I'm going to have to push the door away. But it is an emergency exit. Our main cabin entrance door up front, it's broken down into 2 sections. The height, 66 inches, you really don't have to worry about that because you're stepping up and into the aircraft. You shouldn't be bumping your head. It's used as, it says normal exit and emergency exit. Again, try to brief whenever you pick up passengers. Do not come in from the front side of the aircraft. If they think they can start coming in up here as your rotors are turning up front, it could lead to an accident. The upper portion of the door, opening and closing this door in flight can be tricky. That upper door is on a set of rollers on each side. When it's fully open, it's locked to the rear. You need to slow down below 100 knots. Because if I'm above 100 knots, I've released the lock, I start lowering that door. When it gets about this close to being shut, a Venturi effect is going to take place. And it's going to pull the door this way. And it's not going to stop. Been there, done that. Dropped one in the middle of a parade field one time when I did that. Fortunately, my door went down, but it can go up and go through the rotor system. So we must slow down to 100 knots before closing that door. The lower door, the restriction. To fly with this door down, or to even lower it in flight, I don't know why we would want to be doing that, but to fly with it down, you cannot exceed 60 knots, and it must be locked down. Once the door is lowered down, there is a little lock mechanism here on the side. Pull up on the back side of it, push it forward, and it will lock it down. And if they do enter from the aircraft, passengers are going to enter, make sure they come 90 degrees off the nose of the aircraft. All right, another limitation that we have to be aware of. So far, we've covered the upper cabin door restriction. Closing it was what? Less than 100 knots. Flying with the lower cabin door down was 60 knots. Now then, this door that is on the bottom of the aircraft, we have another limitation that we have to be concerned with, 90 knots. Anytime that this door is in transition, we cannot be exceeding 90 knots. If you're doing it in flight, you've got to slow down below 90 knots or that door will leave the bottom of the aircraft. As long as it is fully open, there are some rubber mounts here on the front part of it. It will swing up a little bit farther and back up against the aircraft with those rubber mounts. As long as it's all the way open or all the way closed, there are no restrictions. But they have put a restriction in there about the 90 knots. It's one of the things to look for on pre-flight before you go out and fly. And if they've got this door open, which 90% of the time when you fly, make sure that those rubber mounts are up against the belly of the aircraft. Because if they're back 2 or 3 inches and you exceed this 90 knots, the strain on the motor, the gears will give away and that door will fall down and it will fall and leave the aircraft. Sternal cargo hooks. We've got 3 of them. Our forward and aft cargo hooks operate off electricity and they operate manually. Our center cargo hook will be operated hydraulically. Center cargo hook, rated at 26,000 pounds. And again, we're going to airframe restrictions with this and the strength of the hook, because we can, with the engines that we've got on this aircraft, we can lift anything. It's mounted at station 331. There are 3 types of releases. First of all, normal release. We want to release it hydraulically if we can. If it cannot be released hydraulically, we would try to blow the air charge that's inside of it and we will release it pneumatically. If that fails to work, we have a manual release that releases all 3 hooks at one time. That will be our last resort of releasing the load. Our forward and aft cargo hooks, rated at 17,000 pounds apiece, located at station 249 and station 409. These are accessible by ground personnel only. Again, this one is not hydraulically. We've got electrical normal release, and then we've got it on another bus, electrical emergency release, and then again the same handle that releases the center cargo hook releases the forward and aft hook manually. Tandem loads, maximum is 25,000 pounds. Remember, what did I say the forward and aft hooks were rated at? 17. We can't add that together and say 34. We have to be aware of the fact, and it happens occasionally, that one of those slings may break, and then it's going to swing forward. That 25,000 does exceed that 17,000 pounds, but it won't rip it out of the bottom of the aircraft. When we go into the water, normal operations, we are limited to be at 36,000 pounds. Emergency rescue operations, we can go in the water at 46,000 pounds. Flotation time, 30 minutes max. That's with the rotors turning or without the rotors turning. I've got to pull it out of the water in 30 minutes. If I've got to be in any longer, I'll pull it up out of the water, let it drain whatever little bit of water gets into the airframe, let it drain out, then put it back in. But I do not need to exceed that 30 minutes of flotation time. Both main tanks, and this goes for the main tanks only, must be at least 50% full. The reason being, we're not worried about fuel getting mixed in with water. Our fuel cells on the outside, fiberglass shaped honeycomb material. On the inside of it are our fuel bladders, or our bags. Inside the main tanks, we have 3 fuel probes. We have 2 fuel pumps. Water is allowed to get in between the fuel cell and the fuel bladder. If that water gets in there and you are less than 50% full, that bladder starts to compress on the inside between the cell and the water, starts to push in on it. You'll start interfering with your boost pump operations. You could knock some lines loose on the inside, develop fuel leaks. So we must be at least 50% of fuel, full of fuel on the main tanks. Water operations at nighttime. Yes, we can put it in the water at nighttime. I've never had the opportunity to do that. But we've got to meet some requirements. Both AFCS must be operational. Both radar altimeters must be operational. Must have a visible horizon, and must have 2 or more visually stationary objects in the water. Master Caution Advisory Panel. We now have 64 lights, which consist of 38 caution, 6 advisory. Maintenance panel in the back. What they've done when they went to the Delta model Chinook was they took all your hydraulic gauges out of the cockpit and we put them in the back. We've also given us some more indications in the back. We've got latch indicators. These little latch black and white little indicators here, if I get a chip light on a number 1 engine, number 2 engine, or a transmission, if it flickers on the master caution panel in the front, this is going to latch and it's going to stay lit. So I don't have to go searching for that flickering or that big piece of chip that may be floating in a transmission anywhere. In the cockpit, on your gauges for the transmissions, you've got selector switches that can tell you which transmission oil pressure that I want to monitor at that time. But we go into the scan position. Scan is looking for the lowest or the highest pressure at that time. Once the master caution light illuminates, it's not going to tell you which transmission. I can take the time if I want to go through the selector switch, find out which one it is, and then initiate the emergency, or start initiating emergency once that light comes on, but some of the emergencies are different. Or I can immediately ask the crew chief. I can tell him I've got a transmission oil pressure light. Which transmission is it? And he can go back there and tell you exactly which one it is. We've got filter change lights in the utility and flight control system. A lot of our components are up top. We can't monitor those in flight. When a filter button pops, it tells us it's becoming clogged. Now we've got an indication on the maintenance panel. But we've got pump fault lights. They'll come on when they feel that the pump's about to fail. They may fail in 5 minutes and they may fail in 5 years, but we have an indication now when a pump is going to fail. And then we have ground contact lights. That's telling you that the aft landing gear are on the ground, and it will desynthesize the AFCS a little bit so that you don't get a lot of erroneous inputs from the wind or whatever from AFCS, some of the stuff that it does for you. Our engines, manufactured by Honeywell. It's a free power turbine 2-stage engine. We can use JP8, JP4, JP5 without making any kind of changes at all. Our shaft horsepower, now this is just per engine. And when we reach our 2.5 minute, 4,867 shaft horsepower, one engine. If we need to go into emergency power, we have the capability of 5,069 shaft horsepower. So in an emergency situation, we have over 10,000 shaft horsepower if we need it. Aircraft fully loaded at your limit of 50,000 pounds, we lose an engine, you have single engine capability. Contingency power on pilot demand. We'll talk about the engines a little bit more in a minute, but we've gone computerized with the 714s. We'll talk about a FADAC system. It's a system, it's not a component. FADAC will consist of a DECU, nothing more than a little computer telling the engine how to operate, when to operate, and it monitors it for faults. And then we've got the HMU, which will be our electrical fuel control. A little cutaway of our engine on the inside. Blue indicates N1 and red should be N2. As you can see, as we suck air in for our N1 inlet turns one way, and then our N2 turns the opposite way. That counter rotating keeps that engine from rolling off the side of the aircraft. But as we are producing power with our N2 section, it's free turbine, and then there is a shaft that rolls through the front portion of it up front. That's where we take our power we're producing out of the back, run it back through the inside of the engine, and it's mounted to our nose box transmission that we'll talk about in a moment in front of the aircraft, and then we distribute the power out a couple of different ways. Our engine control system, what I was alluding to a while ago, is called FADAC. FADAC is a system. It consists of a digital electronic control unit, a DECU, a hydro-mechanical metering assembly, that's our fuel control now. Our transmission and drivetrain system. Again, we've got 5 transmissions. First 2 transmissions that we're going to talk about are our engine nose box transmissions. They take the power from that N2 shaft running through the center of the engine, and they take it and turn it 90 degrees to our combining transmission. Inside of there is a sprag clutch. Again, it allows us for auto rotation. It prevents the rotor system from driving our engines. We always want to be able to drive the engines to drive the rotor system. But if we lose one of our engines, it allows that other engine to completely disengage from the system. It won't drag the rotor down. Combining transmission. This one is one of the most important transmissions that we've got. It takes the power from both engines, receiving it in on the side, and again, it distributes it another 90 degrees, forward and aft. On top of the combining transmission is a reservoir. This is where the oil will be stored for our nose box transmissions. Also on top of it are 3 coolers. The cooler for the combining transmission itself and the cooler for each engine transmission. The aft pylon area here in the front part of the combining transmission, there are 2 cowlings that are on the front of it. If you hear myself or Mr. Borneman refer to clamshell doors, those are what we call the clamshell doors. Open them up and you can look inside, because in the back side of the top part of that are some of the hydraulic components that I know that I will be talking about. Now we get into our drive shafting before we get into our forward and aft transmissions. There are 9 synchronizing drive shafts on this aircraft. 7 between the combining transmission and the forward transmission, and then there's 2 between the combining transmission and the aft transmission. We have 2 engine drive shafts, and then they all have adapters and couplers assemblies. Again, we will break those down. You're going to see pictures when you go out to the flight line of a Pepsi can. It was found inside the drive shafting area here after a flight. The drive shafting area in this aircraft is very important. It will not take long for it to cut itself in half. When you pre-flight the top of this aircraft, look for FOD around those drive shafting. One other component that I want to point out, the aft vertical shaft. It has transmission characteristics, but it is a drive shaft. It has oil pressure switch on it. It has a chip detector on it. It's a drive shaft. It's where we're taking our input from our aft transmission and turning our aft rotor system. You really don't know where to classify it, either as a transmission or a shaft, but it falls in between them. Our forward transmission area. It provides our mounting for our upper controls, our upper dual boost actuators, our flight controls. And our number 1 flight boost pump will be located on the bottom of the forward transmission. Has our swash plate on it, and it's located in the forward crown. When you walk up to the top of the aircraft and you pre-flight it, you've got 2, we call it the doghouse cowling, but there's a door on either side. You can look inside and pre-flight it. And again, our number 1 flight boost pump is located on the forward transmission. That goes to that front and back thing that we talked about earlier. Aft transmission. A few more components are located on the aft transmission than they were on the forward transmission. Our number 1 and number 2 main generators located on the aft transmission. Our number 2 flight boost pump is located on the aft transmission. And then our utility hydraulic pump is located on the aft transmission. And again, like I just mentioned a while ago, that aft vertical shaft fits down on top of the aft transmission to take that rotation from the aft transmission up. One of the things that we've got to be aware of, I told you on the forward transmission was mounted our number 1 flight boost pump. I told you on the aft transmission that his number 2 flight boost was located. That follows that rule that we talked about earlier, front and back. Now you're going to be out on the flight line and somebody's going to ask you, what pump is that? Well, if I was looking at that right side up, that pump is going to be on the number 2 side. But that's not my number 2 flight boost pump. That's my utility pump. The number 2 flight boost pump is on the number 1 side of the aft transmission. Our rotor system, fully articulated. Our rotor blades are made of fiberglass. Each blade weighs 350 pounds. As we go through our flight control classes, you're going to find out that we have at least 4 pumps in our flight control system. Or, as a matter of fact, we got 4. Unlike the TH-67, OH-58, UH-1, you lose your hydraulics, you can still fly those aircraft. If we lose the hydraulic system in this aircraft, you're not going to move the controls. How many rotor blades we got? 6. 350 pounds apiece, that's heavy. Each rotor system weighs anywhere from 400 to 600 pounds, or the rotor heads themselves, that's a lot of weight to move. But our rotor systems, again, fully articulated. What does fully articulated mean? It means that we control the pitch change, lead and lag, and the flap on our rotor system. Is our auxiliary power unit, our APU. It drives a motor/pump. Mounted on the front of the APU is a utility hydraulic motor pump. I need it to be a motor when I start the APU, but just as soon as I get the APU online, it turns into a pump. It will be my utility hydraulic pressure until I get my transmissions turning. Once I get the transmissions turning, then I can cut my APU off and use my utility hydraulic pump. That means that it's a backup. If I lose that utility hydraulic pump, crank the APU up and I've got utility pressure again, hopefully. It's also got a 3rd generator on the back. I use this generator when I crank the aircraft. It runs fine. It operates everything perfectly. So those two generators I have mounted on the aft transmission, if they both fail in flight, I know I've got another backup there. There is redundancy in this aircraft. There's backup after backup after backup. We use it for the APU for ground operations and, like I said, for some in-flight emergencies. It also is going to be controlled with a little white box called an ESU, electronic sequencing unit, just like the engines were, with a DECU. It controls the start. I hit the start switch, it goes through its sequences, it monitors the start for over temperature, pressures, and will shut it off any time that anything is wrong. Our electrical system on the left-hand side of the aircraft will be my #1 system. And the electrical pod up front, in front of the fuel system, you will find that there will be a generator control unit in there for our #1 generator. And our batteries also located inside there, transformer rectifiers. But everything that is on the #1 side will be, or on the left side is #1. Our electrical panel in the cockpit, very simple panel. Battery switch, off, on. APU switch, that's where we start our APU, 3-position switch. And then we've got our 3 generators. Our main generators, located on our aft transmission, 2 of them. They are 40 kVA generators. They are oil cooled. 2 of them, again, 40 kVA, oil cooled. Our next generator is the 20 kVA generator mounted on the APU. Charlie model and below, this was our generators. We had 2 of them mounted to the aft transmission. As you can see now, you've got power for days. We went from having 2 20 kVA generators and everything operating fine. Now we've given you 2 40 kVA generators. We do not have a lot of electrical problems. But this is your backup. This one is not oil cooled, it'd be air cooled. Our DC system, again, it's broken down in the left-hand, right-hand side, #1, #2 side. Transformer rectifiers. Purpose of a transformer rectifier is to do what? AC to DC. Again, we have AC generators in this aircraft. We need to convert it back to DC. Most everything in this aircraft is AC operated, but DC controlled. That's meaning I'm using my switches to open and close relays and let the AC power flow through. One of the things I want to warn you about with our transformer rectifiers, there's one on each side in the little compartments in front of the fuel cells. But on the inside of the aircraft, behind the first 3-man troop seat on the left side and the right side, is a screen. It is a big problem with people throwing their helmet bags behind the troop seats while you go fly. These fans, that's where they suck the air in to keep our transformer rectifiers cool. Do not store anything behind the front 2 seats on either side of the aircraft. If transformer rectifier gets hot, then you're going to need to know what your transformer rectifier emergency procedures are. Batteries. There are 2 different types of batteries. We got the pink batteries out there as the slab batteries, and then we got the blue batteries that are the NiCad batteries. When we are converting again from our 712s to 714s, they are doing the change out, taking the NiCad batteries out of the system. If I have a NiCad battery in the aircraft, also on the left-hand side in that #1 electrical compartment, there will be a battery charger. This was put in the Delta model Chinook to try to trickle charge the NiCad batteries because we were having a problem with thermal runaways. This was to help trickle charge it. It was to monitor it. And with the 712s, if you got a battery malfunction light on the caution panel, then you must know your emergency procedures, reset circuit breakers for the battery charger. But it monitors for over temperature in the battery, cell imbalance. External power. If you're going out to your aircraft in the morning, you see that you've got an APU hooked up to your aircraft, just turn around and go back the other way. We do not need this for anything. I spent 21 years in aviation in Chinooks. I used it 1 time, and that was to convert from the old hydraulic fluid, non-fire resistant, to the fire resistant hydraulic fluid. It was easier to flush the system that way. But we do not use it. It can be used for AC power, DC power, or I can use it for hydraulic power to do any troubleshooting that I need to do with the aircraft. But we do not need it for anything else other than troubleshooting. And again, if it's there, your aircraft's broke. Our fuel system. Again, we got 1,034 gallons. We've got 6 fuel cells, 2 forward aux, 2 aft aux, 2 main tanks. Our aux tanks always empty out into our main tanks. Our main tanks feed our engines. The left side main tank will also feed the APU. The right side main tank will feed your heater. Single point pressure refueling. Now supposedly we can refuel the aircraft in 4 minutes at 55 psi. remember the 55 PSI. But if you do cross-country flights and you stop at a civilian airport, be aware that their pressure may be higher than 55 PSI. If I try to refuel this aircraft any higher than 55 PSI, I will ruin the airframe of this aircraft. It will, once those bladders start overfilling, they're going to crush the stringers and the formers on the inside of the aircraft. I can refuel my internal tanks, the earths, with a single point pressure refueling. Utility hydraulic system. A lot of things work off of this. Once we get in the air, there's not really anything we use off the utility system. But my utility system, when we go through that class, it leads a lot into my flight control system. Our hydraulic reservoir, it's going to be located in the aft pylon area. Between the number 2 engine and the aft pylon, when you go out to pre-flight every day, there will be a panel opened up. Inside that panel, we call it the hydraulic panel, you'll see our utility reservoir on the right, immediately on the right-hand side. You'll see a number 2 flight boost reservoir in front of you and several other components. The reservoir is where we store and cool our fluid till we need it. Our utility pressure control module. If I was standing in the back of the aircraft, facing towards the back of the aircraft, standing underneath the 8-9 drive shaft, I look up to the right-hand side. That will be my pressure control module. There are 5 solenoid valves on the top of that pressure control module. Those 5 solenoid valves allow me to control the flow of fluid out of this, from the pump to all the systems that it needs to go to. So this gives me the ability that if I have a leak in flight in certain areas, I can start isolating those leaks and continue my mission. But we've modularized everything, and it allows us to control those a little bit better. And those are some of the components that it controls the fluid flow to. On the opposite side of that, still standing underneath the 8-9 drive shaft, look over to the left-hand side, is our return control module. After the fluid goes to all the components that it needs to go to, this is the collection point where it gets filtered again prior to going back into our reservoir. There are 3 filter buttons on this return module. On the bottom, there's a filter button telling me when the filter gets clogged. This little button here that I can point to on my slide, that's a pump fault button. That's for my APU pump, that motor pump on front of the APU that I talked about. If it starts to go bad, this button will pop, illuminating the light on my maintenance panel, and then I have an emergency procedure for that. And one that we can't see that's tied in behind these lines is another pump fault button. It's for my utility hydraulic pump. If it starts to fail, it will illuminate a light, and then emergency procedure from there. Again, if those things pop telling me that the pump's about to fail, it could be 5 minutes, it could be 5 years. This little thing on top of the return control module is called a transfer cylinder. It really doesn't hold but about a quart of hydraulic fluid. You'll notice that when you go out and you pre-flight the ramp area, you'll look on either side of the ramp actuating cylinders. They are huge, and they require a lot of hydraulic fluid to operate. When I bring the ramp down, those cylinders need to be full of hydraulic fluid. So this transfer cylinder was put in there to allow us to have a little bit more hydraulic fluid for ramp operations. Our APU Start Accumulator. It's located at Station 555 in the ramp area. You go out. Underneath the aft transmission, there are 2 panels that fold down and back. This is inside on the number 2 engine side. This stores the hydraulic fluid needed for APU start, the pressure and flight. If I need my APU for an emergency and it does not crank, the pressure 3,000 psi of fluid that I've got stored in there can also be used to operate some of the subsystems during an emergency. APU Start Module, located on the number 2 engine side on the inside of the aircraft, Station 584. This is kind of the governor, the brains that tells that APU motor pump when to be a pump and when to be a motor. It works in conjunction with the little electronic sequencing unit for the APU. The signals tell that, again, go tell that motor when to be a pump and when to be a motor. APU motor pump, located on front of the APU. This produces 3,350 psi of pressure. This is the only pump in the system that will produce that much pressure. We need 3,350 psi to start our engines. Keeping in mind that when we're flying along and I have an engine failure in flight, if I need to restart it, I have to start the APU because it's the only thing that gives me the 3,350 to restart that engine. Utility hydraulic pump, located on what side of the aft transmission? Number 2 side of the aft transmission. It will produce 3,000 psi of pressure for me. It will constantly produce 3,000 psi of pressure with a variable flow rate of 0 to 16.5 gallons per minute. Again, once we get in flight, there's not any subsystems off the utility system you're going to need. But you want that 3,000 psi of pressure there in case you need it. So it's always there, but just a variable flow rate. Hand pump. It's a double action pump, meaning every time I pump on it, the pressure is going either way. I'm pushing hydraulic fluid inside that big black accumulator, APU Start Accumulator, with that hand pump. Our fill module, located in the ramp area just a little bit aft of the hand pump. This was not on the Charlie models, B's or C's. Within a year and a half of this being introduced, this paid for itself. Task force went down to South America. On the way back across the water, they developed a hydraulic leak. This allows you to service the hydraulic system in flight or on the ground. Being the crew members they were, they pumped all the hydraulic fluid because that's what goes in there is hydraulic fluid. And they hit land, but it did pay for itself. So remember, we can service this in flight or on the ground. This is on the bottom so that we can get to it, but all our reservoirs are up top. It will pump the fluid to the needed reservoir it needs to go to. Our flight control hydraulic system. It consists of some upper dual boost actuators, power transfer units, another pump, power control unit. Our upper dual boost actuators, no matter what control input we put into the aircraft, whether it be with a cyclic stick, with our pedals, with the thrust, some kind of a movement will go to our upper dual boost actuators. They are mounted up in the forward transmission area and the aft transmission area where there's swash plates. They are two different kinds. There is a swiveling and there is a pivoting actuator. The pivoting, if you look at it on one side of it, no matter which way you look at it, one of the ears should form a P for pivoting. Swiveling will have a bolt going through the middle so it can swivel back and forth. One's on the opposite side of the other. They'll count their pivoting and swiveling movements prevent any kind of lockup of the swash plate up top. They have jam indicator buttons on the top of them. You'll be looking for those during pre-flight. They're just like filter buttons. They can be reset, cycle the controls. If they stay in, they're good to go. And they also operate off 3,000 psi of pressure. As you can see, they control the movements of the swash plate. One side of that actuator is the number 1 system, one side is number 2 system. Should a system fail, never fear, that 3,000 psi of pressure on that opposite piston will drive that actuator. Power transfer units. On the utility side, I have a motor. Once I get the utility APU motor online, it will produce pressure through the back side of this motor, turning another pump, power transfer unit, for our flight controls. I have one in the aft pylon area, one in the forward pylon area, one for the number 1 flight boost system, one for the number 2 flight boost system. When you go out and you crank the aircraft up, you do your flight controls check. These are the pumps that you're using to do your flight controls check. These are also backup pumps. If those flight boost pumps fail on the transmissions, then I have 2 more backup pumps. So again, there we go, start talking about redundancy. If I lose all 4 of those flight boost pumps, I shouldn't have got out of bed that morning. I mean, that's a lot of redundancy there. And the flight control system, we call our control a power control module. What they have done is they have taken the pressure control module and the return control module that we had in the utility system, they've combined them. We do not have all those solenoid valves on top of this one because we can't isolate this system like we could the other system. So they've combined them. Our pressure filter, return filter is there on these. The number 1 is located in the forward pylon area. The number 2 is located in the aft pylon area. They also have filter buttons on them and they have pump fault buttons on them. This is a good picture to show you the number 1 flight boost system in a nutshell. There is the reservoir for the number 1 flight boost reservoir, or for the flight boost system. From the reservoir during our engine starts, fluid will go to our PTUs, power transfer units. From our power transfer units, it will go to our power control modules and then be distributed out to wherever it needs to go. But our flight control systems do not have a lot of components. They operate a lot of components, but that's pretty much a flight control system in a nutshell. Pumps, Forward transmission, I've already told you where that was at. Number 2 is on the number 1 side of the aft transmission. This produces 3,000 psi of pressure constantly with a variable flow rate of 0 to 16.5 gallons per minute at 100% rotor. All 3 of the pumps, both flight boost pumps and the utility pump, are the same pump. If I look them up in the parts manual, they all have the same part number, they have the same stock number. It's just a matter of where they're mounted and what lines are hooked up to them. Our hydraulic panel on the overhead console switch. As you start looking through your dash 10, they're going to refer to something as called an isolation switch. There's nothing on that panel called an isolation switch. What they are talking about is once we develop a leak in the utility system, is the ability to isolate something. If my power steering leaks, I can either flip this switch up and disable the power steering right there, or I can reach down on my center console and just turn off the power steering. Because you're going to find out when we go through class that that one switch right there will actually disable 3 systems. I got power steering, swivel locks, and brakes on this switch. But if I can isolate it just by turning my power steering switch off, I've isolated that system. I can turn to control the flow of fluid to my ramp. I can turn it off or I can turn it on. My power transfer units, since they operate off of the utility system, if one of those start to leak, I can turn it off. But again, there is nothing on there that's marked isolation switch, just the ability to isolate something. Lower control pressure control module. When I reach in there and I turn off my AFCS, I am turning off hydraulic pressure at the lower control pressure control module. These are located inside the flight control closet. Also, you're going to find out that everything in the flight control closet operates off 1500 psi. This is where it gets reduced down to the 1500 psi. Upper dual boost actuators, we want 3000 psi. Flight control closet, we want 1500 psi. Our integrated lower control actuators, our ILCAs, located in the flight control closet. These are what operate off of 1500 psi. There are 2 portions of this. There is a boost side. The boost side of the extensible or the ILCAs is something that we cannot control the pressure to. We want 1500 psi of pressure going there all the time. When you make a pilot input, that is the hydraulic boost that you get from moving the controls. The extensible link side is our AFCS side. In our pitch, our roll, and our yaw, we have an extensible link. That is where the AFCS inputs go to. Anything that's introduced to the aircraft input-wise other than a pilot input, it's trying to dampen those out. But we have 2 AFCS computers inside their avionics compartment, identical in operation. So that tells us we've got 2 separate systems. I can lose one system and it should not affect the other systems. Some of the things that it does for us is pitch out attitude hold, bank angle hold. When I go into a bank turn, pick out the bank angle I want to and I can hold it there. And it's going to continue to go in that little circle that I've just put it in all day long until I either run out of gas or I pull it back up. It will not continue to roll over. Heading hold. From the time I pick this aircraft up to a hover, it is going to hold the heading for you. As long as my swivels are locked, it will hold the heading. Airspeed hold, altitude hold, and motion dampening. Those are things that it does for you. This is Cadillac. It's almost fully coupled. AFCS, again, some of the things that are in there. We've got a dash actuator and a pitch system that provides for pitch attitude stability, airspeed hold, and a positive stick gradient, meaning helping us that whenever we nose this thing over, try to get 160 knots out of it, the LCTs, the dash actuator, are all going to work in conjunction, level that fuselage back out for me, but it's still going to hold it at 160 knots for me. Our HSI, we were talking about that, the heading hold and some of the features that it has. Our HSI, once we get our aircraft set up and we've got a straight and level flight, if I need to change the heading, I find my little heading bug, I grab the little heading selector knob there on the bottom, I turn it, and the aircraft's going to start turning to wherever I turn my heading bug. Once you get this aircraft set up with AFCS and you start your flights, it's pretty much I can kick back and read a newspaper. But we know we all got to keep our hands on the controls and watch out what's going on out there. But it is set up with AFCS to do a lot of the things for you.